in this video, we're going to do a couple more examples dealing with properties of the trig functions in using the unit circle. So the first one here, suppose theta has a terminal side that goes through the point -1 root 3. We want to find the values of all the trig functions. Now this one doesn't say that it's on the unit circle, okay, but it is on some circle. So I'm going to draw the one that it is on. Okay, and we're going to have to determine the radius later. Okay, so -1 root 3, so that's the x is negative and the y value is positive. So it's going to be somewhere up here. Okay, then if I make this, so that's the radius. So it should, okay, so this has, oops, it's the x value. So this is 1 or -1, and then the height here is root 3. So then when we find the r value, so r is the square root of -1 squared plus root 3 squared. So that's 1 plus 3 inside the square root. So that's square root of 4, which is 2. So the radius is 2 here. So now we can find all the trig values. So our theta, okay, is that. So it has this as its terminal side with that point on it. So sine theta is going to be the y value over the r value. So that's root 3 over 2. Cos theta is the x value over the radius, so -1 over 2. And tan theta is the y value over the x value, so that's -root 3. Okay, and then cosecant theta is the flip of sine theta, so that's 2 over root 3, or 2 root 3 over 3 if you rationalize the denominator. Secant theta is going to be -2 over 1, or -2. And cotan theta is going to be -1 over root 3. And again, if you want to rationalize, that's -root 3 over 3. So that's that one. Okay, couple more down here. So here we want to find tan of 19 pi by 6. Okay, so this is in radians. Remember the period for tan is pi. So 19 pi by 6, we can subtract pi to get something with the same tan value. So pi is 6 pi by 6. So if I take away 6, that's going to be 13 pi by 6. Okay, minus another pi, that's going to be 7 pi by 6. And actually I could do even another pi and get another one that has the same trig value, tan value. So that's just going to be pi by 6. Okay, so this tan is equal to tan of pi by 6. And tan of pi by 6, so I don't know, I'm going to go to sine and cosine. So it's sine of pi by 6 over cos of pi by 6, which is going to be 1/2 over root 3 over 2, which is 1 over root 3. Okay, a couple more. So cos of -390. So because cosine is even, this is actually cosine of positive, oops, not 360, 390. Okay, now we can also, so let me just write here, so this is since cos theta is an even function. Okay, now 390 is bigger than 360, so it's more than a full turn. So a coterminal angle is going to be, if I subtract 360, which is going to be cosine of 30 degrees. Okay, so those are coterminal, so the cosine values are equal. And cosine of 30 degrees is root 3 over 2. Okay, now tan of negative pi by 6, that's going to be negative tan of pi by 6. Again, this is since tan theta is odd. Okay, now tan of pi by 6, actually we just did that one. So it's 1 over root 3. Negative, sorry, because of the negative out front. So negative 1 over root 3. So those are just a few examples using the unit circle or circle in general, even in oddness and the coterminal angles, or the period.